Alright, how's everybody doing? My name is Judah and welcome to another video. So this is actually the start of a new video series where I'm going to be talking about how to go from knowing zero about a programming language to having a functional understanding of it and being comfortable reading and writing it. And I thought the best way to do that would be to learn a programming language I know nothing about, or well, not nothing, but I know very little about, and turn that into a series so we can learn together. So the language I'm going to be tackling is Scala. So Scala is an object-oriented, sort of functional by design programming language that lets you do a lot of really sort of weird and interesting things. It also has interoperability, if I can say that properly, with Java. So you can chuck Java libraries into a Scala program. So you don't have to learn Scala to get anything out of this series. If you wanted to, say, learn Python or Scheme or Lua or whatever, you could totally do that and follow along. This is just going to be showing how I approach learning a language, and how you can approach learning a language as well. So let's get started. So the first thing I do is I open up a terminal. If you don't know how to use the terminal, I highly recommend it. It is a really amazing tool, and it makes things much simpler. Just period. So if you're on Windows, I would recommend getting something called the Windows Subsystem, or Windows Linux Subsystem, I think is what it's called. It's called WSL, or WLS, however you want to say it. But if you look up basically Linux on Windows, if you have Windows 10, you can just directly download a Linux virtual machine inside Windows that can just run kind of like how mine would be running. Because I'm on Linux. If you're on Mac, you can also just open up your terminal. So if you do the command space, type in terminal, you can open that up and you are ready to go. You can basically use all the same commands I use besides one or two, and I'll explain that as we go along. So once you have your terminal, once I would have my terminal up, I will open up a web browser and I'm going to go to the home page of the language I want to learn. So in this case, we're going to go to Scala. We're going to look that up, and if my internet will speed up, we can do that. So this is the Scala homepage, so I'm just going to go to download, and I'm going to look at what it wants. So I need to have JDK and yada yada yada. Now for me, I already installed it. I use Manjaro Linux, which is Arch Linux. You don't really need to care about that, but I have something called a package manager, and that means I can literally just type in this and then the name of the thing I want to install. So in this case, Scala. Type in my password. I just typed it in wrong, and I knew I typed it in wrong. But you can type in your password, and it'll show this, right? And so I can install the package if I want to. Boom. And now I have Scala on my computer. The other package I had to install was one called SBT. Which is Scala's sort of packagey, managery, buildy, processy sort of all-in-one solution for a lot of things that Scala needs to do. I'm not going to be using it in the first, couple episodes of this because I want to just bare bones it. That's just what I like to do. I don't like to get all bogged down with build systems and all that crazy stuff. But whatever language you're trying to learn, go to their homepage and look at what you need. If you see a package name like this, right, and you know how to use a package manager, so if you're on like Debian, you could use apt-get, or what is a D package, and then if you're on Ubuntu, apt-get, whatever the difference would be, and then just install Scala. This is for Mac, so on Mac you can literally type in, like I said in terminal, just brew update or brew install, and that's going to be your package manager. So after you do that, I'm just going to make a nice little directory for all of these episodes, and that is just going to be living in my Scala directory. So if you don't know how to do that, just mkdir on Linux, and then you can do that. All right, so I'm just going to cd in my project directory and create a test.scala file. Whoops, and then go back to the Scala homepage, and actually the documentation, and we're going to look at a tour. I usually like to just jump into a tour because a tour kind of just gets you up and running with syntax. if I was starting from like scratch, where I literally would just like have only heard the name of the language and I know nothing about it, I would try to go to the getting started and see and look for something to tell me how to compile or run Scala programs. I know with Scala, I can literally just do Scala C and then good to go. So I'm going to go to the tour of Scala, right? And that'll just give me, the rundown of all the stuff. But in another tab, I'm going to open the website Learn X in Y. Oops. Wait, Learn X in Y, I think. Oh, learnxinYminutes.com. This is a great, really awesome website with a ton of languages. Basically, most languages you would ever want to learn will be on this website, and we'll have a description or like an explanation of how they work. So for instance, I'll just type in Scala. And so, for instance, this gives you the setup, how to use the REPL, right? So a REPL is like what we did on REPL.it. So I can just type commands in if I wanted to. So for instance, I can go Scala, go like 1 + 1, and that will show me a res0, which I'm assuming is a variable, right? So can I print that? Let's see, res0, yep, and there we go. And I can't use clear. Can I use clear? No. Who cares? But as you can see, a REPL is a really good way to play around, right, with the values. So I can do like random math things. Get 0. Whoops. I can do like, what is it? I think it is var. Let me see. Oh, val. So val x equals 256, right? And I should be able to type x. Yep. I can go like print x times x, right? And so we can do all that stuff. So REPL is a really good tool for doing this kind of stuff, just kind of playing around with the language. And that's what this can show you for languages that support it. But we're just going to keep this up as a quick reference. So for instance, defining a function, I can just tell by experience, this is the type of this value. This is the type of this value. This is the type of the function, the return type of the function. Like Ruby, we don't have to use the return keyword if the last value is an expression. So as you can see, this is an expression x2 + y2. Since the function returns an int, good to go. And it even says so up here, right? If you come from more traditional languages, notice the omission of the return keyword. Scala, last expression in the function block is the return value. Boom. So I'm actually curious if Scala even has a return keyword. So let's test it out. So def add x, y, int, capitalized. Actually, I'll go full statically typed. And I think this is actually required. Let's see. And we're just going to do return x + y, and boom. Okay, so there is a return keyword. There's like an explicit return. Let's just see. 1 and 2. And we get 3. So it is working. So you can use return in Scala, apparently. Great. So let's actually get started writing code. So I like to do projects when I write code. I think the more code you can write that is related to you is the best thing you can do. For instance, when I learned Perl, which was sort of my first sort of jump into programming, or my first like serious jump into programming, I tried to automate everything I ever did on a computer using Perl for like 6 months. I think it was about that long. So I was checking out a lot of like books at the library for like random things. So I literally wrote a program that managed my library book checkout. So try to find use cases that are interesting to you. All right, so let's get nerdtree open and neovim and do all our fun stuff. And now we're in the file, so we can go back to the tour. So let's see, this tour contains bite-sized introductions to the most frequently used features of Scala. It's intended for newcomers to the language. It's just a brief tour, not a full language tutorial. If you want a more detailed guide, consider getting a book or other resources, right? So I'll just click this. Let's see who writes these books. So I like O'Reilly. They write a lot of good books. If you're more of a book person and not really a like on-the-job sort of person, I highly recommend O'Reilly. Also, No Starch Press and Manning. These are the 3 people I always go to for books if I ever want to learn something the more academic way. So Scala is a modern multi-paradigm programming language designed to express common programming patterns in a concise, elegant, and type-safe way. It seamlessly integrates with and is a pure object-oriented language, meaning everything is an object that makes sense coming from its sort of Java background. In the sense that every value is an object, like I just said. Types and behaviors of objects are described by classes and traits. Ooh, we got some Rust type stuff going on. I think Rust has traits, if I'm not mistaken. Maybe I'm forgetting. Classes can be extended by subclassing and used by using flexible mixin based composition. Ooh, mixins. We got virtual classes, I think. All right. So I will come back to that later. Furthermore, Scala's notion of pattern matching naturally extends to the processing of XML data. Ooh, I don't know about that one, Chief. XML data. All right, well, this will be exciting. Is this a... wow. That is... Right, so let's just jump into it and write something. So the first thing we need to do is we need to look at if there's an entry point, a particular entry point. And I think there is, because if everything in Scala is supposed to be a class, right, or an object, most likely we're going to have some like C# Java type stuff where we need to make a class program or a class whatever. And let's just, yeah, okay, main method is the entry point of every Scala program. The Java virtual machine requires a main method named main that takes one argument, an array of strings. So we're about to learn a ton of stuff with just that little thingy. So we need to create an object, which is, I guess, different from a class. And it told me above, but I skipped over it. So we have an object main, and we define a main function or a method, and we give it a argument of args that hits an array of strings. I also really, really love the capitalized types. I don't know why. So let's do the tried and true hello world. And we don't do semicolons. And let me just quickly see what an object is, just to make sure I'm not going to get anything, too wrong. So objects are single instances with their own definitions. You can think of them as singletons of their own class. You can define objects with the object keyword. You can access an object by referring to its name. Very interesting. So I'm going to quit out of that, quickly open something called tmux, which allows me to just have multiple windows in my terminal, like so, right? So I can kind of, be hackerman, right? And then go back and be compilerman. So I'm going to be doing that. So we'll do Scala C test.scala. Oh, geez.
2,000 years later.
All right, so we compile with Scala C and then run with Scala main. All right, great. So let's just double check that the printing multiple times will work, right? Recompiling and then running the same thing yields the same results. So I'll put this works. And good, so that doesn't recompile. What if I just do, okay, so I can't do Scala C by itself. And now I need to do Scala main, and there we go. Now we're going to put this in one command. We can do it with the double and essentially all that does, that says, if this command succeeds, then run this one. If this one fails, do not run this one. So that's basically what the double and does in Bash or in Linux. But great, now we have that. So let's quickly try to just loop through all of our args, and we'll actually do this. Since we're making a console application, we're going to make one that just, says, this is a little tough question, or a little tough design choice. Let's just do one that takes a person's name and then says hello to them, right? So it's just like everyone's first program in a language, something simple, and then we'll move on from there. So let me just look up a for loop. So for loop. So this is list comprehension, but I'm looking for a for loop. Okay, so we have a for each, and we have Da 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 da. So let's first get the length of something, and I think I can do that, yep, with the dot length. So I should be able to go, let's just check their if statements. If I need to use a, yes I do. Okay. So we're going to go if args.length is less than or equal to 0. So if we didn't get any args, we're going to define another method called usage, right? And that isn't going to do anything besides printing out the usage string. And I think, is there a void type? Let's see, recursive function is an explicit return type, which is analogous to, analogous, yes. That is the right word. So let me look through the types. So I do not see is there a nil? Is there a null? Or is there a void? I think void is the right one, right? So I will just do void, right? There we go. I'm assuming that will work. So what we're going to do is we're going to go print line, and that's just going to say usage. It wouldn't be our program name. Well, I guess we could use our program name, which is a good chance to learn about string interpolation. So let's quickly make a private variable, and I think we can do that with the what? Private? Privates. Let's see. Size methods protected by private keywords are also available. But can we do a private variable? The values in these classes tend to be private and only methods are exposed. That's a case class. Creates a type and a singleton instance of it. It is a common Scala class to have a companion object where the per instance behavior is da 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 da. The difference is similar to class versus type with general languages. Okay, great. So that didn't really tell me what I needed. So we're just going to assume we can. So we're going to go private var, or actually, sorry, isn't it? Okay, so this is val. I think val is for immutable values, and I think var is for variables. Let's see. Oh wait, sorry, I completely skipped over that. Declaring value is done using either var or val. Val declarations are immutable, whereas vars are mutable. All right, cool. Good to know. So we'll do private val name equals greeter, or gretter. Let's do greeter. That doesn't look right for some reason. I don't know why. Okay, so how do we access self in this? Do we have this? Is there a self? That is the real question. So we'll do self, or what is it? This dot, or do we just access the actual thing? So let's see. So as you can see, we're already learning just a ton of stuff just by trying to work through a problem. So I've already learned, you can declare immutable values with val, mutable with var. This is how you define functions, right? We can do if statements or conditionals like so. And I just also learned that this has string interpolation using an S before a string. So we'll do name and then name. All right, cool. Oh, I think my headphones might be dying. Doesn't matter. So let's just quickly do this. So if args.length is less than or equal to 0, usage, right? And then can I do an exit? Is that a thing? Let me just double check exit.
A few moments later.
So we can do system.exit and we'll pass 0, right? Because that's not supposed to be an error. So let's try to compile and see if we get an error. And we do. The type mismatch. System.exit takes, let's maybe just that. Let's see. Not enough arguments for this method exit. It takes x1 of type int, unspecified value parameter x $1. If I pass in a 0, it doesn't seem to like that, and that gets a type mismatch. Found a unit required void. This is an interesting problem. Let's see why it takes that. So is a void method. Oh, right. So it is returning something. So the reason why this is happening is because since this is something that returns a value, our function is supposed to return void, right? So our function is supposed to return void, but instead it's returning whatever system.exit returns. So is there some way we can throw this value away? I just want to quickly see, is there a defer? Is there? No. So for this case, we'll do an int. Actually, what we'll do is, yeah, we'll just do an int. We'll just make it easy. Return int, and this is just going to return. So I like using explicit returns in my code, even if a language does it sort of implicitly. I just like being explicit with, when I'm trying to return a value. That's just something I like to do. It's more of just a stylistic thing. So we compiled, and we're getting one error, and it says found a unit required int. So this is actually not an int. This is a unit. Interestingly enough, whatever a unit is in Scala, which we'll have to look that up. All right, great. So now we actually have our code, and it's running. So now if I do Scala main, we get just that because we didn't pass any arguments. If I pass an argument, it doesn't do anything. So far, so good. So now what we'll do is we'll do some list comprehension-y cool things, or actually, sorry, we'll do a for each. So we first put the list of things, then for each, and then an expression, or whatever this is called in Scala. So in this case, we'll do args for each, and then we'll have to do a, oh, that's really nice. We can just do a function right after. That is crazy looking. I love this. And that should just print everything that we pass. So let's see. This is a test. So we should see this is a test. Yeah, that's really interesting. Okay, and we can also do it a little more explicitly, like so, and print line x. So if we wanted to, say, make this do a lot more, do that. Awesome. So I think this is how we open up a block of code. And so we can do like an anonymous sort of function, which I love this syntax. This is just so simple, and it completely makes sense. And I absolutely, that's great. So let's see. We can go print line, and we'll do x plus. Let's do another new line, right? So it's essentially printing it multiple new lines. So it should be 2 new lines per thing we're printing. And it's exactly what it does. So we can do plus for concatenation. Let's see. So we'll do x, or actually, sorry, let's make this more cool. So we can do x like this. I should do the exact same thing. And there you go. So I actually love this. It's kind of like Perl, how we can substitute just values using the $sign instead of string. Awesome. So let's go to val name equals args 0. I'm assuming, let's hope that things are 0 indexed. So I can go print line. We'll make it an S string. We'll go hello, name. And this should be our program. Let's go like this, and we'll go Judah. And we get an error. So value args of type array string does not take type parameters. All right, let's see indexing. Index. Oh. To access elements of a tuple, use underscore dot underscore n, where n is the one-based index of the element. Oh, geez, is this a one-base? Is this a one-based language? Oh, and we actually use parentheses. Whoa, that's interesting. So we'll go if args.length is less than equal to 1, and I think we can actually just use a switch statement for this. This is probably actually the best case because we have a lot of if statements that are kind of focused on the same thing, which is just how many arguments we actually get. In this case, let's see, switch. Pattern matching might look familiar to the switch statement. Oh, I think we're a little too far down. No, okay. Just look up, wait a second, let me just check pattern matching. Pattern matching is a powerful and commonly used feature in Scala. Here's how you pattern match a case class. Can't talk. NB. I don't know what that means. So we could totally just do this, right? This actually will work. Or sorry, should work. And whoa, that's cool. Not what I was expecting. And I can see why that didn't work. And I swear, okay, so that's not what we do. If I do args.0, I'm going to try this really quick. This shouldn't work, but I just want to see what happens. Okay, so how do we use that properly? And we'll just actually do this. We'll just bind it. Go val name, and we'll go full on args0. What we could do is if we wanted to do this cheaply, we could, oh wow, weird. For I 0 until a.length. So I'm not really a functional programmer. So if you're a functional programmer and know a lot about functional programming and you go, oh, this is so easy, you just got to use I will have no clue what you're talking about for the most part. This is a first for me, so I'm especially vulnerable in this series. So let's go with our imperative, our tried and true imperative for loop, which we can do like this. So for I arrow 0 until args.length. So we'll go if I equals args.length, because I think this should be inclusive. We'll do the Oxford comma plus name plus and plus name. I'm just going to write it in a dumb way. Otherwise, we print, it should be, well, we can actually do it like this. So we'll do a couple print statements. We'll go hello, comma, like so. And now it will be, whoopsie. We'll go print, how do we equal? Okay, so, okay, this solves our problem from earlier, actually. So we wrap it in like a bash expression, like a bash script kind of thing. That's weird. I love that. So we'll go args I, right? And then we need to add a comma to it, so we'll do a plus and a comma. And in this case, we'll just do an S string. So we need to do it like this, and it goes args I, comma, and space. And then finally, we will do a print of and, right? And if I can type properly, args I, right? This should run properly. Let's see. So get that. Oh, what did I mess up? Where did I screw that up? So line 22. Did I hit close? I should probably just read the error message. Error, boom expected, but found boom on line 22. So we expected to find one of these, and instead we found one of those, and that was the problem. So we should just get one guy. Hello, Jim. Hello, John. Hello, Jim, John. So already a glaring issue. So him, Jim, John, and Judah. So already a glaring issue, trailing, and we get that character of the unterminated value. So what we need to do is we need to go if it is length -1, because we are doing this the proper way. So we're doing it twice, and that should be a break. At didn't get syntax highlighted, so I don't think it has a break. So let's figure out Scala break for loop. Let's see. Break statement. Do I really have to type in loop dot? No, whoa. We have to, so breaks aren't supported by default. We have to make a breakable object. A breakable object and then break out. Okay, so that tells me that we should do this not how we were supposed to. We should do this in a different way. Let's do a return. And there we go. So that's quote unquote clean way to do it in the imperative style. which I know a lot of people are probably not going to like that. Man, not a huge fan of this cascading Java-looking object. That is definitely not something I'm down with. But right, so let's double check this. Let's double check our work. We run with nothing. We get our usage string. Right. If I run with one name, we get just one person. If I run with two names, right? So I'll number myself like thing1, thing2. We get hello, Judah, comma, and Judah. And so that's not actually what we want. So now we can remove this. We can just go print. Sorry, I couldn't think for a second. So we'll go print args0, because we're only going to use it in one spot, plus a new line character. Right. And then we can do a printf, or sorry, just a print of an s string that is going to be hello, boom, and boom, and then a new line, and that will be our args0 and our args1. So now we can clean this bit of code up, and I think that is good. And now we can also abstract away this new line character, because we're always going to be doing a new line at the end of our print, right? So if we want to, we could remove this, and instead, after this bit of code, we could do like a print like that. That's not really pretty looking, but it would be a way to abstract that new line character from repeating and cropping up into these three places. And so we'll actually do that just to do it, because why not? Right? Why not try to just, do something a little better? Even though I think it's very ugly, and I don't think I would do this normally, if I'm being completely honest. So if we run our tests, actually, oh no, a spoiler alert. If we do this, boom, we should just get our usage. We do that. Should get one name. If I do that, we should get two names separated by an and then if I do that, we should get boom, boom, and boom. There we go. And the new line character isn't printing because we're returning, because instead of breaking, we are returning instead. And if you watched the last video, you probably know how much I hate the else statement in most things. In this case, we'll actually use it because we can't break out of a for loop like how we could in another language. So now that we have this, boom, and everything is printing beautifully. All right, so now we have a very basic understanding of how Scala works, right? We know we need to define an object main, right, that has our main method, or the entry point of our program. We know what it takes, what it returns, right? We know how to make a method that just, prints our usage and then returns a system.exit, system being, I'm assuming, a module that we can call from that's imported by default, or it's a part of the standard library. We learned how match statements work, right? Where we can call match on a value and then use case to go statement by statement. We know there's no fall through. So these blocks that I added, or these brackets, actually don't matter. I can do this, and I can do this, if I can type properly. So we also saw how for loops work, right? So how imperative style for loops work. We can do a set variable that is going to be the iterator in our loop, right? We can assign it to a value with the arrow, go like arrow syntax. And I'm going to use an until and then a value, right? So until being a, I would say, inclusive loop counter, I guess would be the right term. So in this case, we're looping from 0 until the length of our loop, the length of our array of strings, right? And we won't go over because it's only until I equals that. So we check our if statement, and we say if we're at the last one, then we want to do that Oxford comma E sort of and whatever. Otherwise, we just print our value. Since we didn't have a break statement, we couldn't break out of this loop. So that tells me that for loops aren't super supported in Scala, that Scala would rather you do it differently. So maybe in the next video, I will work on changing this into a better program. So once again, thank you for watching, and I will see you all in in the next video where we try to make this better. All right, see you then.